Alright, so I think I'm recording. Let's take a look at problems 7 and 8. The directions here are asking us to determine the intervals over which the function is increasing, decreasing, or constant, and also to determine whether the function is even, odd, or neither. We've been in the previous problems using a yellow highlighter for increasing, a green highlighter for the intervals over which it's decreasing, and an orange highlighter, or at least I think it's orange, for where the function remains constant. The end of the graphs, the edge of the graphs here, indicating that they've shown us this up and down pattern, and now the graph is going down and to the left forever and up and to the right over here forever. So this arrow gives us two pieces of information about the x's that are going to negative infinity, and information about the y's that are also going to negative infinity. Here on the right, that gives us two pieces of information about the x's that are going off to positive infinity, information about the y's that are going off to positive infinity. So let's use yellow to indicate where the function is increasing. As I trace out the graph moving from left to right, I have to be going up. So the function is increasing here. It changes and I go down. So over this portion it's decreasing. Then it changes again and I go increasing. Then it changes again and I go decreasing. And then it changes again and I go increasing on up forever. So there was no portion of the graph anywhere that was constant. So let's describe the intervals over which the function is increasing. It's happening in 3 intervals, so we'll need 2 union symbols. On the left here, the x is coming, as we enter the graph from the left and as we move from left to right through the graph, from negative infinity all the way to the x-coordinate here, which is negative 3, the function, any 2 points, as x increases, y also increases, it's an increasing function. Or, if we're on any portion of the graph that has an x-coordinate that is between negative 1 and positive 1, those points, as x increases, y is increasing. So here x is from negative 1 all the way here from x to be positive 1. If x is in those interval of values, if the point has an x-coordinate that is in that interval from negative 1 to positive 1, as x increases, y will increase in that interval. Or the x-coordinate of this point is 3, all the way for values of x that are larger than 3, any 2 points, as x increases, y increases. So notice that we did need 2 union symbols here because we had a total of 3 intervals over which the function was increasing. Where is the function decreasing? We've highlighted that in green. We want the x-coordinates of the endpoints, if there is an endpoint. Here, the x-coordinate is negative 3. As x increases, to stay on the graph, y will have to decrease. That's true from negative 3 to x equals negative 1. And union is also true from x is 1 to x is 3. For constant, it's never constant. So we can say never, we can say nowhere, or we can use the empty set, which is just a 0 and a slash through it. Alright, now let's determine if the function is increasing, or excuse me, even, odd, or neither. So let me erase this work. I can see that the left-hand side of the graph is not a mirror image. This is going up, but it's not going up as high, and it's not going, it's not in the right spot. We do not have symmetry with respect to the y-axis. This is not an even function. Now, it is going through the origin, but let's take a closer look. If we rotate the graph 180 degrees, do we get the same graph? Well, looks to be a little bit of the same shape. Let's look and see. At -3, at 3 units to the left, 3 units up, 3 units to the left, 3 units up, 1 unit to the left, 1 unit down, left, down, 1 unit to the right, 1 unit up, and 3 to the right, 3 down, 3 to the right, 3 down. It's going up there, it's going up there. Looks to be an odd function to me. Alright, let's take a look at problem number 8. In the previous videos I've been using orange for constant, yellow for increasing, green for decreasing. We see here at the edge of the graph where it's printed that they've shown us that the change here, this is going off to the left, and we continue that pattern. We can assume that it continues that pattern, so we put arrows there. That's giving us this time just a single piece of information, well, 2 pieces of information, that the x's are going to negative infinity, but the y's are remaining constant. And the same thing here, the x is going to positive infinity, but the y values are remaining constant. So as I enter the graph on the left, I know that until I get to this point, which has an x-coordinate of -5, the function is constant. The function is also constant over here. Now, it's not the same constant value, but the function is constant. In this interval, as x changes, y remains constant. If you're greater than -5 and smaller, if the x-coordinate, if you have 2 points that have x-coordinates that are bigger than -5 yet smaller than +7, as x increases, y will have to increase. Alright, so this function is increasing over that interval. The x-coordinate here is a -5. The x-coordinate here is a +7. The function is never decreasing. So we can write never or nowhere, or just simply use the empty set. The function is constant in 2 intervals, from negative infinity to an x-coordinate of -5, union an x value of 7 off to infinity. The y value is constant. So if you're in this interval, if the point is if we're in this interval or in this interval, as x increases, y will remain constant in both of those intervals. Now, let's determine whether the function is even, odd, or neither. Let's erase this. We clearly do not have symmetry with respect to the y-axis, because this part that's going up to the right like that would have to go like that and over, and it doesn't, so I know that it's not an even function. Now, for an odd function, it is passing through the origin, but when we rotate it 180 degrees, will we get the same? It looks kind of the same. However, on the right here, this point out at 7 is 7 units up. Well, out at 7 and 7 units up, we're not even a point on the graph. It is to the right and it is up, but this is not the same graph. Down over here, left 5 and down 5, and we have to go left 7 and down 7. So it is not odd. So since it's not even and it's not odd, it must be neither. Alright, so let's take a look at the next one. Or did I do? Let's see. I did 7 and 8. Alright, so hey, let's do the next pair of, on the next video. So I hope this helps.